Hello everyone, this is Brady. So previously I've made a procedural folding fan using the newest geometry nodes. I used a method to make up a UV that will stick with geometry regardless of deformation. So today I'm going to make another animation, a similar kind of animation that I've done in the animation nodes in the past that requires the same techniques. So let's just start. So here we're in Blender and I'm going to the noding. Here I'm not 100% sure if I need to make a plane or not because it probably does not really want a plane. I want to create a grid so that I can have more kind of procedural control with how many vertices I actually have. So in this case I'm going to turn on the wireframe because I want to see how many cuts I have. So in this case let's make the sides a kind of 1.28 and 0.72. So this is basically the dimension of the image that we're going to have. Let's maybe we can increase the size a little bit. And for the cuts, it does not really matter because it's completely free. Basically, just to know that the cuts is basically finally defines how we actually deal with the grid later. In this case, maybe I would like to have more cuts, a little bit more. So 15 and 12, something like that. The size does not need to be a square, so probably, yeah, I would say these may be just fine. Next thing is I want to create another new grid that has different indices, because now the indices, I'm not 100% sure the indices, but I assume this is 1, this is 2, this is 3, and this is 4. And then we start to have 5, 6. This is the way how computer actually thinks. My illustration here may not be 100% accurate, but it should be similar. The whole point is that it does not run in order. Next thing I'm going to do is to actually shuffle this list so that the index should be completely randomized. So maybe 1 here, 2 here, 3 here, 4 there. So basically the shuffling the list. This cannot be directly done within geometry nodes, so we have to use a little bit of workaround in this kind of grid shuffle list. So first thing I'm going to do, I'm going to arrange the viewport a little bit so that we have a larger area for the node tree. I'm going to put the entire mesh into the points, and to visualize the points, so mesh to points, and to visualize the points, it will be better if we instance on the points. Otherwise, you'll probably see nothing from my screen. So take the 16. This is really just for visualization, so it does not really matter how you actually do that. Just to make sure it's kind of small so that it does not interrupt what we have done. So now basically we have points from the either vertices or the faces. Currently it does not really matter, but I think essentially we're going to, it does not, essentially it does not really matter. So let's just set a position. What do we really would like to do, however? Meshed points can also set a position. So maybe we can actually deal with the position here as well. I'm going to create a random value, and I'm going to use a preset which is called a negative. Take the type into vector so that the negative values, original values. By creating this original, we're actually trying to make a kind of length, a kind of 3D volume. Okay. And I'm going to vector mask to eliminate all the values on the axis. So this is a grid. But this is not a formal grid. All the kind of points are completely just randomized. In this case, I'm going to use a snap function so that they form essentially a grid. And I think something like this should be good enough. Let's take the 1.28 and 0.72 so that it matches the ratio. But one thing I realized, it's not the same grid that we saw earlier. I'm not sure the reason, but either I think I will just stick with this randomly generated grid instead of the original grid. Now what do we need to do is to fill all these kind of gaps. So I'm going to point instance. So that's the basically reason it does not work. It seems like we do not have enough, because as we are generating random values, it's very possible that all these kind of points overlap to each other. Okay, so in this case, I'm going to generate a geometry mesh line, so that and set the offset to 0. So essentially, we're duplicating all this kind of grid in the same location. Next step is to realize the instances, so that finally, if we increase the resolution, then we fill up the grid. I think this is okay, and just by decreasing a little bit the values, now we start to have this kind of new grid. And notice that the vertices, all these kind of points are having different indices, because essentially these are generated from random value. So maybe the first point is generated here, next point is generated there, and so on and so forth. So the indices are being randomized, which is essentially what we want. There is also another issue, however, is all these kind of points are essentially overlapping to each other, because there are so many points that are being generated, probably 35 times 15 times 11. So there are probably 1,000 points generated within this grid. In this case, since we do not have the merge by distance node yet within geometry nodes, we probably need to add a wield modifier, so that's finally eliminate all these kind of points. Okay, because in this setup currently we're using an external modifier, which means we cannot really accomplish everything within a single node tree for the moment. So I'm going to firstly mute these instances, because we no longer need to visualize all these kind of points for this moment. In this case, I need to create a new object to do the same thing. So let's firstly put the seed into the group input, so that we can actually change that for different objects. Next step is to create a duplicate. So basically shift D. So let's name the first as A, the second as B. So now we have two the same mesh, but once I'm changing the seeds for this geometry node tree, then the seed to generate all this kind of random value, which means the indices will actually also be different. And then finally, I'm going to create a new object. It can be any object, just whatever. I'm going to select the cube. And I'm going to create a new geometry node tree. Let's name that as animation. And I'm not going to use the geometry. I'm going to use the geometry of A and B. So select our object A, select our object B. So once we put A's, then we start to visualize object A. Okay. If we put the object B, then we visualize object B. They seem the same. However, they are different because of indices. Here we're going to mix their position together. Here, let's take the mix. You can use mix. I've explained pretty many times. You can use mix RGB or mix vector presets. In this case, because this is a simple setup, I'm going to use the mix RGB. And we need to put the geometry data to the A. So transfer attribute transfer. Based on indices, because the indices is essentially, at least they have the same count. So the indices can be transferred 1 to 1. And transfer the position. Take the position into, so here, let's see, and immediately we see some effect, and at 0, then we'll use the original position that's linked to this geometry, and this geometry is geometry A. So we're using, so at the 0 factor, we're at the geometry, the position or indices of geometry A. But once the factor goes to 1, then it forms another grid whose indices is based on, whose position is based on the geometry B. So this is how field being worked or being read. Okay, so now we have all these kind of points, and we can deal with this animation. It's pretty kind of interesting and cool. Here, let's instance the grid onto all these kind of points. And this is no longer just for visualization, because this is really going to be a part of our animation. So now we have this kind of grid. and so now we have a nice grid being spaced out. If you do not have look at so maybe you can tweak the value a little bit better. It just kind of requires a little bit of precise controls, like 0.09, 0.09. Yeah, probably a little bit lower. But 0.081. Yeah, something like that. It's just DCs are not very kind of important, so I will forgive that. But here I realize, despite the general shape is like kind of rectangle, but the kind of individual grid is like a square. So this reminds me, when we set up these kind of parameters, there are two kinds of control. One is controlling the general shape with this multiply. Another, I think, it's the snap function that finally determines the ratio of each individual grid. Because if you snap the same values, then the spacing between here and here are the same. Okay, you can tweak it in your free times, but in this case, I think I will just stop here with this kind of grid instancing thing. And instead, I start to move on with more about the animation. But I also think maybe you think this animation is already completed, so we're going to start with the shading first, and then we work with the mixing animation. If you ever worry about the shading, this is pretty straightforward. So we're going to shift the D to duplicate this mesh, and then I'm going to apply the instances. I'll apply the modifier, and so now we keep the entire the same mesh, and I realize there's too many vertices than it should, so it's probably because our grid is having too many vertices. Okay, so let's delete this mesh and redo everything again. So having more vertices does not cause any problem, but I just don't like it because it seems to be bad. Okay, so now we have the correct amount of vertices. Goes to UV editor. This object currently does not contain any UV, or even if it has a UV layer, probably no, but it's just not correct. So here we just project from view with bounds, and this ratio is not correct for this object, but it's simply because the image that we're viewing is a square. So in this case, we do not need to worry about that. Directly go into the shaders and add a whatever texture. And the Control T, so that we have image textures. Add a image textures, goes to the shader view, and now we have this image texture. Okay, so this is cool, and we're going to transfer the image textures to our grid here. So let's go to the geometry node tree, and I would like to rename this object. So let's this is GN, the other is UV, so that I have a clear mind about which object am I working with. And within GN, I'm going to take the object info, and finally take the UV and transfer attribute. And the target is actually means the source where you want to get the attribute from. The UV is a 2D vector, so vector point. And this domain should be face corner because the UV is actually within the face corner. If you select the UV, you can see the UV is actually in face corner domain. So we get everything's checklist vector index face corner. Okay, fine. And the geometry into the target attributes. We do not have the kind of attribute node for UV at this moment. Maybe I don't know when you're watching this tutorial. But maybe in the future you will start to get any kind of get attribute or UV attribute node, whatever stuff. In such kind of case, please just use the UV node, whatever stuff, as you should. In this case, we are going to access attributes in a kind of more dumb way, but it actually works. So here we access everything from the modifier panel. Within this attribute, let's hit this cross and type the UV map. Note that previously we see two UV map. One is because it's the original object is a cube, remember? So this is the UV map for the cube, and this is the new UV map that we just projected. By the way, we do not have delete attribute nodes. So in such kind of case, this UV map will probably just stay there forever with this claim. Anyway, so we have the UV map. We are going to output these attributes. The way to output the attribute will also be the same as we do attribute with here. Okay, so now we have done everything. Just goes to the group nodes, and we are having to set what's kind of domain data as well. So goes to face corner, vector name does not really matter. Okay, and then type the same UV map. The reason is that the only way for the how should I say, the object to recognize the UV map is to match the name, which is UV map. So even if our object actually there's nothing within the spreadsheet. The reason it has nothing in the spreadsheet is because if your mouse hover here in the instances, you can see it outputs 180 instances, and the instances are essentially empties. Empties has no UV data, no anything. It's just empty, just like the empty you see elsewhere. Just the shift A, you see empty. Where's my empty? Yes, these are empties. So in this case, we have to convert everything back to mesh, which is also called realization. So now we have everything in face corner. You can see there big UV map, small UV map. We have to use the big UV map because this is how the geometry nodes will recognize. Okay, for some reason, another thing is if you look at if you try to get the materials as we did for the original UV object, there's nothing changed. This is abnormal because at least you should get a color. This is because every time you instance within geometry nodes, something bad, you cannot, it's on the whatever object, the mesh, whatever stuff. But it just recommend you to actually set material using nodes in this case and type in material, and immediately you change the color. It does not provide a clear image because the UV data is messed up in such kind of case. I will just tolerate that for the moment, and let's just actually duplicate this mesh, and let's say the output. Okay, and I'm going to select the map in the output because I'm going to edit that a little bit. So here within this UV, it actually does not work. We have to use the UV map. I'm not sure exactly why, but you just have to do that. And another thing is that the eevee does not read data very well. I'm not sure exactly the reason, but you have to switch to cycle. So let's go to cycle. So now we start to have the image. So maybe in the future eevee will be improved so that it can read all this kind of attributes, but this is the case. So again to remind you that for some reason this UV map won't really work, but you have to use the UV map. Okay. Here I'm going to fix this texture a little bit by putting this color into the emission, so that's so now it should be better. Okay. Specular down, roughness down. So now we have this image, which is cool. And more importantly, is that if you play the animation, so initially if you play the factors into 1, then you have all this kind of crazy stuff that will be there, and then if you put the factor back to 0, then you form the image. Oh, this is amazing. Yes, okay, this is cool. Another thing you should realize, where is that? The seed you can change, so that's you can change the seed. Everything is procedural. Amazing. I actually pretty like I like this pretty much. So randomized, now everything has been formed back to the image texture. Okay, this is cool. Just to know that because this UV isn't 100% procedural, so but I don't think it really takes a lot of energy if you try to just duplicate and apply the modifier and select all the meshes projected from views or other things. I admit there are quite many steps, but it actually works. So in the meantime, unless we have a better system to do all this kind of stuff, I think this is the way that you should go for this UV projection. So now we basically have finished this animation. The only issue is like it's kind of in the reverse order. It might be more intuitive if the factor goes 0 to 1 so that it goes to complete image. But now this is the reverse order because we are duplicating our mesh in the state of factor 0, so the indices is complete when it's factor 0. Anyway, but this is not really a big problem, so I'll probably forgive that. So there is so basically you can actually make this animation more complex because I think this already looks kind of good and interesting, but from point to point it goes a straight line from start to end. Maybe you want to complicate the animation, it does not really matter. So but I think I will stop the tutorial here and do the rest parts in my meantime, because it might be too complicated to even think about. But before I cut off this tutorial, I also would like to mention that in the moment that we are doing this kind of transition, everything is occurring on the same plane actually. So in this kind of case, you might cause a lot of z-fighting because you do not know which plane to actually show on the top. So you will have a lot of clipping issues. Sometimes it's just kind of flashing around. In such a kind of case, it will just be very easy just to take a vector mask and take a random value, combine x, y, z, take the vectors to place and then take the maybe 0.5. 0.5 should be enough. Then you can see all these kind of polygons flying apart. So in this case, you really manage to decrease any possibility of z-fighting. You can see it's a more kind of easy transition. And in the orthographic view, which is kind of top view, that you do not really see any distance, any perspective that shows you, oh, this is not a plane. But this is not really a plane because these are actually tons of lots of polygons on different z-axis. Okay, and you can plug with the delay fold and with the time info. So I updated the delay fold so it might look just a little bit horrible with many different settings. But the type of duration, so the usage, however, is not very different from the past. You can tweak all this kind of value. Just know the duration is basically the time take the 0 to 1. And I also added the is function. So take the factor, everything is complete at this moment. We need to map range to make it reverse order. So take the minimum to maximum. And now let's play the animation. Maybe it's a little bit too fast. Okay, so this is kind of okay with a little bit of delay. Otherwise, you just take the too much step interval, then it's kind of too slow, which is okay. It's not too bad. I would say it's not too bad. I'm going to clamp the value at 1. Clamp the value to 1 is actually too much. Hey, I'm going to take the durations 15. So this is actually too much. I think there are some bugs within this preset, but I think in the meantime it shouldn't be. It should still be kind of workable, and it's also possible that you create your own presets to do whatever stuff that you want. But in this case, I'll probably say this is yet. So you can play around with all these kind of settings, and I hope I can deal with these presets better. And definitely it's possible to make kind of more complex animations, depends on what you actually do. But here I probably will just stop here for today. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.